So what I wanted to do next, and tell me if I'm being too loud, if I tend to be loud, is I wanted to walk through a set of use case examples and talk about how this concept of data mining and characterization is not isolated to researcher access or even public access, that it actually ends up being important for almost every stage of the life cycle, at least as we are starting to support it amongst the types of projects that we engage in. I'm not going to speak to anything in kind of the archival context or the WAS or NetArchive, WCT. These are all contexts where what we're doing is we're taking individual tools, resource functions, workflows, and dynamically assembling them based on the requirements of a particular effort at a given point in time. So what's becoming increasingly prevalent, at least at the Internet Archive, is this need to be able to reinvent, if you will, the framework for a particular project each time we have a new effort come into being. But it also has had profound implications for ongoing work. So what I thought I'd do is primarily provide sort of a baseline around this concept of a national domain harvest. And our colleagues in New Zealand were kind enough to let me talk about the project that we worked on in the last 2 months for their libraries and archives. But I'll also filter in examples from focus collections and some just web-wide crawling that gives you a flavor of how this may or may not scale, how it differs when you have these different use cases and contexts. If there's other things that you'd like me to layer in, please let me know. But one of the first things I'm going to do, I think this will actually,
Yeah, the down.
Is it frozen? Hang on a second. Did it work? Aha! So very quickly, I'm not going to spend a lot of time on this slide, but just to sort of put this as a frame of reference. Traditionally we had, when you're talking about a specific crawl, a set of activities that were executed in a particular order. In this case, you might seed and scope a collection. You might engage in some body of deduplication and other harvesting criteria. You'd ingest the content that was then collected, process it in different forms, index it for various forms of access, potentially mine and analyze that in support of both access services, reporting, but also automated quality assurance, that would get folded back into sort of the next crawl cycle. But what I wanted to talk about is kind of the moving away from that, sort of some of the range of things that, and this is not in an order anymore, it just happened, I just used the same circle because it was easy. To talk about some of the components that we now sort of peer into and the range of frameworks that are deployed to try to understand what's happening at any given stage of a process and some of the tools that are included in that. Aaron will get into the details on the tools, but I did want to talk a little bit about this context because I think it's changed dramatically in the past 5 years. We are doing a lot more analysis of the target resource before we ever officially begin a project. All of that content becomes part of the core corpus and it's considered production output. But like, for example, in the case of a national domain crawl, and I'll use New Zealand as an example, you would have the registry data for .nz. So that all comes in, and each domain is articulated for that particular domain. But we also do analysis on .net, .name, .org, and .com in order to identify any resources that are geographically located in New Zealand and include that in the corpus of the official seed list. There are other types of analyses that go into the complexities around treatment of robots at different layers of particular target resources based on the complexity of their national policy about what they're allowed to ignore and collect. So what we will engage in to kind of frame that process is what we call a survey crawl, where we visit the top level page of every host that's identified as being within scope, and we collect in a very robust way all of the material associated with that top level page, and then actually mine it. We visit it with browser, we visit it with crawler, we actually go and then mine both logs and the written output, we compare it. Often, we did not, in this particular project, create a live snapshot of the resource. We did create snapshots of the archive resources. For other types of crawls that we've engaged in the archive, we would also obviously create a live snapshot, or a snapshot of the live resource. But this gives you kind of a feel for the range of analyses that we're engaged in, from crawl log analysis, browser and response log analysis, direct access of feeds. We're creating web graphs and doing embed and outlink analysis. We may also translate that all the way through to generating inlinks and looking at anchor text, potentially indexing anchor text, description text, and or the full text of certain resources in order to identify content that should be included within collections. And then we're prioritizing what we learn about that general space and trying to determine if there are unique collection mechanisms that we have to deploy and at what scale in order to support that in any sort of life cycle. So that just hopefully gives you a general idea of all the raw material that might be assembled in different orders. What I want to do now is just quickly walk through some of the different stages of the life cycle and give you some concrete examples of what we're doing at each stage. As I mentioned, in the national domain context, there's a tremendous amount of work on trying to understand where the scope of the collection begins and ends, what is in the national domain. And this gets particularly challenging when you're leaving, in this case, .nz, and you're spilling into .com or .net. Trying to determine what are the criteria is, of course, the job of the institution who owns the collection. But what we try to do is surface up what are the range of options for making those decisions upon and how that might map into a set of policy decisions. So, for example, there was a tremendous amount of effort in this last cycle to try to determine at what layer into specific social media and aggregation points we would go, and how much content, for example, we would collect from a YouTube body of content versus, or Facebook that might be connected to .nz resources versus what was excluded from considering to be in scope. And we used page rank mechanisms for looking at the prevalence of outlinks to specific resources that lived outside of the domain, or the traditional national domain. We also used inlink analysis to prioritize certain resources that, again, connected back into the domain, that were felt to be potentially strongly connected to the culture, society, and other criteria that the library was using for inclusion. So those are some of the range of things that we engage in. For focus crawls, like the elections crawl that we did in the US during most of last summer and last fall, we engaged in a very similar methodology. We would have, in one context, 300 to 500 curatorially identified seeds. In another context, we had more like 9,000, manually curated resources that needed to be assembled in a collection bucket, if you will. But we took the same general approach that I just described for the domain crawl, and and we first surveyed those resources, we tried to identify all of the content that might have been linked out to that should have been included in the scope that maybe hadn't been identified because there's no way even a body of very diligent curators can go out to 9,000 websites and navigate all the links and figure out what the meaningful connections might look like in a very short amount of time. So these are sort of methodologies that appear to apply at large-scale focus crawl scale, but also at domain scale. The embed analysis that's done when we survey a particular body of targets becomes really useful. We use that to precede collection via traditional crawl processes that we might engage in. We use the heritage crawler, but whatever crawler you might be implementing, knowing ahead of time what resources are required to render a page, or at least are communicated back to a client that are required. And we found that if you only use the browser to and mine the response logs to record that interaction, there's some body of content that's identified. But if you actually then go and crawl those top level pages and do a more traditional embed analysis on those resources, you find additional material that you wouldn't have identified via a browser process. So we're actually using both methodologies for trying to optimize the input to these capture cycles. We then return to it later and confirm what's working, what hasn't, and run these types of analysis again at a later stage. So that's kind of an insight into the collecting part, and I'm not going to speak to each of these, but these just give you some ideas of some of the things going on behind the scenes in the browser. This is an example of a response log recorded by actually a headless browser cluster that we maintain in the archive for all of our projects that we route through, where we can go and specify that the communication between client and server can be recorded and outputted, and then we can use it to mine information that we need to either see to crawl and or engage in automated quality assurance against those collections. One of the things that we are doing in order to facilitate this is, obviously, if we had to go back and act on a work file every time we wanted to run one of these analyses, we'd be dead in the water. We wouldn't get to engage in any of this. So we actually have two types of mechanisms that we've been using for this, depending upon the scale of the effort that we're engaged in. I'm not going to spend a lot of time on this because I'm sure Aaron will drill in a little bit, but
I know where you got that smiley face.
He knows where you got my smiley face.
See it in my slides.
Exactly. I borrowed it from Aaron. It's his smiley face. But anyway, we've created a draft format for extracted link content and metadata that also includes a certain amount of not only the text of the link, anchor text, but a certain body of text on either side of the link. Because sometimes the link just says click here, not very helpful when you're trying to actually identify the nature of the link itself. So sometimes the interesting text lives on either side of the link. That's all included in sort of the draft spec that we've implemented. We now generate these files by default for all the collections that we are facilitating. So as we're writing to work, we're generating a CDX shard and we're generating a WAP file. And we can pull that into a data mining environment that allows us to do the kinds of operations that I've been describing. To give you an idea, though, of how large this can sometimes be, for the web-wide crawl that we ran, the 0005 crawl, it's about 360 terabytes of compressed work data. The WAP file data set is over 62 terabytes. So it's not a small amount of data in terms of the ratio. The CDX is much smaller and nimble, and so you can do some work against the CDX in successful ways if you didn't want to engage in WAP files. But for a domain crawl, like the National Library of New Zealand's crawl, the WAP data set was substantially smaller. We ended up with something in the neighborhood of less than a terabyte of data. So that's a very nimble and flexible amount of data. Certainly when you're just doing the survey crawl at the beginning of a process, that is super compact and easy to manipulate with lots of data. So it wouldn't be prohibitive for individual institutions to consider doing that, even if just at the survey level of a particular collection. In terms of the capture or sort of monitoring active collection stage of the life cycle, we've sort of prioritized a couple of different things. One, the embed analysis becomes really important in this concept of completeness. We know we can't be 100% complete. We're not going to capture everything that's required to re-render a resource. But we shouldn't be missing the low-hanging fruit or the things that could be identified through these various methods. So a lot of the data mining that we've invested in is really at trying to improve the individual quality of captures. And the snapshots have helped in two forms. We've been able to kind of skip over or gloss over some of the re-rendering issues. If you can take a quick peek at the live resource, and then at least get a sense of the snapshot that's generated from the archive, you very immediately can see whether or not there might be some issues, and then you only drill through on resources that look like they might have issues, and you can try to isolate from the report outputs and from other supporting tools whether or not the content's written into the archive and just can't be effectively re-rendered, or whether or not there's content missing. And we've really tried to reduce the impact on the human beings that have to do the quality assurance, where they're not going out and QAing resources where there's files missing, that it's just never going to be a good use of anyone's time, because there's content missing, and so the timing of that human-based quality assurance would really be inappropriate. So what we're trying to do is, where resources might be more completely assembled, we can start QA while crawls are in progress and not wait for collections to complete. And where it makes no sense for a human being to take a look at a resource, they're not wasting time doing that. The other thing that we are doing quite extensively is we have a similar architecture to Julian, in the sense that we have these URI databases that are assembled in HBase. They support different types of purposes. In some cases, they're supporting deduplication and live crawling. In other cases, we are using them to support different forms of access. But one of the other things we've assembled in kind of our data mining environment is an ability to shoot logs into an implementation of Hive, which I won't get into the details of, because I'm sure Aaron will touch on. That's also deployed in Hadoop, that allows us to very quickly mine crawl logs and detect patterns of spam, content farms, scoping mistakes become very, very visible, and we don't have to deploy as much resource to the local crawler to try to mine locally while the crawl is in progress. We're able to separate those two things, and the crawl continues aggressively and as comprehensively as possible, while the assessment of where things might be going well or not so well is happening in sort of this other context. We do the same thing with browser logs and other types of analyses, but there's a lot of assessment that's happening while the crawl is in progress. 3 or 4 years ago, it used to be something that you had to wait until the majority of the crawl completed in order to get anything out of it, with the exception of crawl logs. In terms of sort of characterization of the collections, one of the things that's been hugely beneficial is we're doing more and more work around routing based on format profiles. So when we do survey, there are certain types of resources that we absolutely know we want to prioritize to route through. For example, a browser-based analysis or capture mechanism. We're executing JavaScript and AJAX and other types of frameworks to try to identify resources in those contexts. Those get prioritized for cycling through these shared infrastructures. At the scale that we're crawling, even in a national domain context, it's impossible today, because we don't have the infrastructure of Google, to be able to route everything through those mechanisms. So we have to make decisions on how deeply we run these analysis. It's not every page of every resource, for lack of a better way of describing it. It's not really a page anymore, but you get the idea. We have to try to be selective and strategic around what we're actually routing through these resources to complete this in an efficient time frame. Because what we are effectively trying to avoid is too much of a time skew, where by the time we've identified what needs to be collected, it's actually changed or disappeared. And it may sound crazy that in a 4 to 5 week window of time that much could change. We've had situations where we visit one body of resources for a target on one day, and by Wednesday those resources are no longer accessible in the way that they were identified. So the timeliness and the issues around collecting in a timely way and in a strategic way cannot be overstated. Some of the other applications that we're using in this context is trying to do more around assessments of deduplication that's URI independent. And we're using primarily, we experimented a little bit with the MongoDB implementation, but we've standardized on HBase for all of this activity now. But we're really trying to understand within a collection and identifying some of that duplication before it gets into a full-text search indexing process. Historically, Aaron would always be the first guy to tell us, hey, this is the rate of duplication I'm seeing in this national domain crawl. So now we don't have to wait until an entire full-text indexing process has occurred to identify some of those issues. And where that becomes important is, we tend to optimize for politeness in collection and making sure that hosts that are located in the same IP address range are not, successively hammered and all that, those types of important criteria that go into collecting. But it's just as important for us to know that there's an entire mirror of a resource, located under a slightly different set of addresses, so that we can work with our collecting partners to determine what's the priority around that, how do you want to represent that in your collection, and be more thoughtful about that process. The other opportunity that we've engaged in quite extensively, primarily from a focus crawl perspective, but we've also used these techniques at domain scale, at least at some layers into the collection, is this idea of being able to use data mining to map the path that certain rich media resources actually need to follow in order to be replayed. So it's nothing that an end user would see, but it's a set of mechanisms and workflows that we've developed to try to say, okay, here's a unique ID for a particular video asset, for example, and here's all of the permutations and paths we had to follow to collect that puppy. And guess what? That process and workflow changes every 6 weeks. We don't want to have to constantly worry about how that process is happening. We have to on the collection end of the spectrum, but there's more and more robust ways of actually collecting. So the challenge we then have is how do we actually document for a body of replay resources how to actually pull this out of an archive. So we're starting to use data mining to generate automated rules for trying to replay content natively from an archive and from an archive page versus having to surface it in a separate body of reports. We end up doing both to expedite and accelerate quality assurance, but that's just another example of how we're using data mining for this purpose. And finally, we've not leveraged this extensively yet, but there's certainly a huge opportunity to do more in the area of language detection, of having enough body of text, and that's something that we're still trying to work through. And Julian is doing a lot of native language detection as things are flowing in to his data repository. Those types of things I think are going to be more and more important to build into the default workflow for many of these projects and programs. In terms of the access end of the spectrum, a lot of what we are trying to design now is this concept of using data mining and metadata generation that would combine both the curatorial input when something is nominated with automated metadata extraction, which Aaron will talk about in greater detail, so that you have what we're loosely referring to as almost like a host profile, so that you could actually surface up meaningful information around a particular target that may evolve over time, obviously. So we're applying this concept to snapshot-based collection development, like the national domain harvest that might only happen once a year or once a quarter. But we're also trying to scale this up even to sort of our web-wide collections and our web-wide archives. To be perfectly honest, the most robust profiles, though, have existed where we've had strong curatorial input, where, for example, in the term collections, we have subject matter experts who have gone in and classified by branch of government. They've written or at least identified the official title of a particular target resource, provided other types of metadata or description that's much more robust than what the webmaster who owns the site might have inserted something, as illuminating as welcome. So you get the full range, but certainly I don't want anyone to walk away from this presentation thinking that human involvement is not important. It's critically important to have quality content, even in this web context. Some of the other things that we're working on, and I'm hoping some of these links will work, but we'll see. We've got a number of implementations where we're generating link graphs, tag clouds, and other visualizations, either at the collection level or at the archive level over time. And Aaron will probably pull these up as well, so I don't want to spend too much time on this now. And you'll be able to kind of navigate through this later. We've also started to do work with some of the snapshots that are generated from the archival content, and where we have snapshots that were generated from live resources, where you can see time series evolution of, for example, we've got one here, an example that's the front page of the New York Times from 96 to 2010. But there's some really interesting things that you can start to do when you have these elements that are more accessible to your general public. In terms of searching, in general, we've not implemented full text search across collections larger than our domain crawls, our archivic collections in combination, partly just due to the infrastructure and the resources required around that. However, we are using sort of our infrastructure to extract and repurpose the description text, the title text, some of the keywords that we can clearly determine have not been spammed to generate bigrams. We are piping that metadata through full text search engines like implementations in Solar to start to experiment with, could you actually, is it sufficient amount of content to create a meaningful search experience as a starting point to get greater visibility into resources at different points in time. And then I just quickly wanted to mention some of the research tools and access that are starting to be built on top of these data formats. So the first project is actually one that started at USC Annenberg School of Communication. Matt Weber, who's now professor at Rutgers University, sort of incubated this concept of a history tracker where you could actually go through and mine and create sub-collections of content from archives and repackage them for more traditional social science research. He's working with a professor named David Lazar at Northeastern, who also does research at Harvard as well. He was at Harvard in the past. And David does a lot of visualization on top of web-based data sets and looking at network effects, relationships between, for example, how organizations, and Matt does a lot of this research as well, how organizations manifest in traditional offline contexts and how they interrelate in online contexts, looking at wide-scale network analysis. So a lot of the work that we have with them now is trying to expose a broad body of content in this format of metadata and linked data sets with some text-based content, and see how far they can push sort of the research envelope without having to actually work directly against work content. So that's the History Tracker project. Ahmed had talked to you a little bit about ArcLink. That's the idea of putting an API on top of CDXs and WAT files and exposing visibility into collections in ways that we don't currently implement. And there's additional work going on with the Memento team to try to figure out what actually gets pulled up into the native exchange of that API level versus what might be available in more of an ArcLink context. And I just wanted to show you a couple visual illustrations or examples of where we're trying to go with this. These are examples of potential future host-based profiles whereby we can surface things like keywords, snapshots over time, what sort of access rates to these types of records. We may create host-based full-text indexes, so you might be able to search the New York Times from '96 to the present from the archive, but you may not be able to search the whole archive. So there's all kinds of work we're doing to try to figure out how we might be able to innovate at this layer, but with a longitudinal framework in mind. And we're really having to leverage this data mining approach in order to make this possible. And this is just a quick illustration of the latest iteration of the History Tracker tool, which is leveraging pig scripts, which are all going to be, they're in GitHub currently, publicly available for download if you wanted to experiment with them. But as the project proceeds over the next 2 to 3 years, there will be documentation, shared code for acting on any work content and WAT content or extracted metadata content. So it sort of raises the need within this community to try to figure out what, if any, standards do we want to frame for that extracted metadata in combination with curatorially generated metadata that can then be packaged for various access services, purposes, and research use. So that's sort of the... Oops. So that was kind of my injury web archiving walkthrough and how data mining is now introduced at each stage. Do you have any questions, or do you want me to talk more about a specific use case?
Yeah, just some clarification questions. Okay, so has the University of has the New Zealand domain crawl been basically only crawl where you kind of implemented these kind of pre-crawl survey crawls?
Yeah, we do that with every crawl we execute now. So every crawl that we're executing for the Library of Congress on a weekly and monthly basis follows the same basic framework. It has different combinations, if you will, of tools being entered into different stages of the life cycle. Those are all large-scale focus crawls that are done assembled on a frequency bucket. So there's lots of crawls within those contexts. We have utilized these same approaches for other domain harvests that we've implemented. I don't want to speak about those because I didn't get permission from the partners to discuss them. But suffice it to say, we've implemented this technique on a wide range of domains. We also run survey crawls for the Internet Archive at domain scale on a regular basis that apply these same techniques. Where we probably have the biggest gaps today is for the web-wide crawling. It's not feasible for us to run every resource through a browser-based analysis or capture mechanism. But we are doing aggressive capture via browser proxy implementations for certain aggregations. So YouTube video that we crawl exhaustively based on sort of the end user prioritization of what's the most popular content. So we grab as much as we can in any given day. That's all being written and captured entirely through a browser implementation and written work.
So, just one more thing. So that, in terms of quantifiable, right? So how much time and resources do you devote to this kind of pre-crawl analysis and data mining and generation of
So,
datasets?
yeah, I'm going to let Aaron speak to some of the characteristics of our infrastructure. Ours probably takes a short amount of time because we have pretty large body of resource that we can throw against it. So for a domain scale survey crawl that may have, say, 100 million, targets in it, we can do sort of the crawling and processing of that measured in a handful of days. So that pre-analysis happens very quickly. It's very lightweight when you're only capturing the top level of a particular resource. Where it's hairy is when you start to get down into those resources. And so in any crawl, there's always things that you find as you start to get deeper. But that initial analysis does not take as much time as you might expect, and it pays off extensively. We normally budget about a week, but we can do it faster than that if we need to.
Do you have any figures on, you said that you apply more complex crawling processes for everything? Do you have any idea of the percentage of how much to the number of targets or percentage of which it has like more complex? And is it the same for different crawls, or do you apply different thresholds for different crawls?
So what we're doing now is for a domain scale crawl, we run everything through a browser-based analysis, and we do an actual traditional crawl that we then mine and analyze. So we don't care how large the domain is, but at domain scale, we're doing that consistently. Where we aren't doing it is for the web-wide crawls. It's just way too many targets. We can't do that for those broader crawls. Any host that we come across, we're going to first prioritize collection by traditional methods, and then we're going to do some analysis during the crawl and post-crawl to figure out which ones might need to be routed to specialized services for collection.
If you're applying specialized services, do you know what kind of percentage of sets would need that?
So I'm not sure that we, I'd have to follow up with you on that for the web-wide stats. We just optimized the snapshot generation so we can take snapshots of any live host we encounter in the web-wide crawl. So that was sort of the first order of priority. But I'll see if there's specific statistics there. In terms of the domain scale, I think that what I can say is the general trend is that a higher and higher percentage of resources benefit. And the reason that we're doing both types of analyses in the beginning is because a high percentage of those hosts in a domain need that level of analysis. Otherwise, we wouldn't do it that way. To be perfectly frank, it's a lot of resource for us to dedicate.